Welcome to the K20 Center's Zoom Into Your Career video series. These online career expos give students a way to explore many interesting careers and learn about their career options from volunteer professionals. Justin LaRose is a senior software engineer working in the technology, product, and experience business unit at Comcast. Justin has worked on a variety of projects, which includes the Emmy Award-winning television guide Xperience.
Thank you for this opportunity to share with you guys. As Jamie mentioned, my name is Justin LaRose. I am a senior software engineer. I was actually employed at a telecom company / entertainment company, Comcast, up until last week, in which I actually took some time to try a new opportunity at a new company. And this week I started a new job as a senior software engineer at Dell Computer or Dell Technologies. So this is my first week at that employer, and I've been having a great time. Just to give you some background on what a software engineer is, I am basically a builder of software. So an engineer is just a person that builds things, whether it's bridges, buildings, or software. And I've been doing this for roughly 15 years. I started my career in right after college at a tech support organization in which they built dental software. So they built software for dental offices in which they needed to be able to take appointments and get your x-rays, input it into the computer, bill insurance companies, and receive payment from their customers. And that was mainly how I got into the software biz. And ever since then, I've just enjoyed working in technology, and my career has progressed ever since. I could go into some more details on what my day-to-day is. When at my career at Comcast, I worked on a project that was for the television guide system. So when you're at home and using your television and wanting to tune to watch, let's say, like HBO or NBC, you have to interface with your television using a guide. And that guide system allows a customer to looks at what's going to be coming up, upcoming, or even record television shows that they might be interested in watching in the future. So my role as an engineer there, I worked, software sometimes can be divided into sort of two major components. You can have your front end software, which is more of the presentation in which the user interacts with. So when you're on your iPhone or your Android, the different apps that you have and the different icons that you interact with is often referred to as the front end, because that's the main component that you're interacting with. And then there is in software, which is referred to as backend systems. And these backend systems tend to be components that you don't even know as a user exist, but they are actually sort of like the brains behind a lot of the functions that happen. For example, if you want to send a text message, you might type in on the front end, "Hello, are you there?" But then when you hit send, what happens behind the scenes is what the backend systems perform. And I was more of a backend engineer. So I worked with a lot of data. I mainly was responsible for a series of services that handle things such as your preferences. So when you were watching TV and you needed to turn on closed captioning, which is a popular feature for people who watch TV. That setting could either be set to on or off. And we need to store that data somewhere so that when you return later on to watch your show, that setting is consistent throughout your viewing experience. You wouldn't want to maybe turn off your TV and then turn it back on and have to turn that functionality back on. So one of my responsibilities is making and maintaining the service that stores that value of whether true or false is on for closed captioning. And one of the things that makes my job exciting is that it comes with a variety of times where you have to problem solve. And if problem solving is something that you're really good at, I think a career in whether it be software engineering or any type of engineer, I think that is a ideal role for a person that's really good at that. Some of the other qualities I think that play well with being in engineering is being really good at math. With understanding how computers work, a lot of it has to do with calculating in computing functions, and all that kind of goes well with knowing math well. But there is other opportunities within the software industry that aren't necessarily in the software development area. There's other opportunities such as QA. QA stands for quality assurance. Quality assurance is a field in which after someone develops a particular feature, so let's go back to the example of a text message, right? If you're building a software that sends text messages, it should send text messages. Well, the QA person or the quality assurance person will write a few tests to make sure that that feature is performing like it's designed to do, which would be sending different types of text messages, seeing if the person that's on the other end receives it. There's also an area of operations is another area in software development, which involves that engineer making sure that the software keeps on running. Software runs on hardware such as computers or servers somewhere, and these things need to be maintained and upgraded and need to be functioning at all times. And that's the role of an operations person. And then there's other roles where if a person's really good at art, one of the things that we look for when making software is designing it very well so that it's a good user experience. So there's actually roles called UX. UX stands for user experience designers that make sure that when someone picks up a piece of software, it's friendly to use, it's intuitive, meaning that you look at the software and you're able to kind of determine on your own how to use it without having a lot of instructions. And then they come up with the ways of making it appealing to the eye. When you are comparing different softwares, especially that are for consumers such as apps on a smartphone, you want to make sure that it uses the right colors, it uses the right icons and things like that. All those things drive a customer to continue to use your product. And then there's other roles such as product managers. A product manager is the one that typically comes up with the ideas. Like there's a new feature that needs to be added to an app. And this product manager will figure out the ways in which this feature can be designed and developed and make sure that they have the research to back up that this feature is something that the customers want. And then one of the other roles that are involved with developing software is project managers. Project managers are typically people that keep the project on track when they're developing the software. They go through the process of the planning phase and coming up with a schedule in which they expect this feature to be completed. They make sure that people aren't blocked, meaning they aren't prevented from continuing to do productive work so that they can be efficient with the time that they have. So there's a variety of roles that a person could take when building software. So it's not just the development roles that I mentioned earlier. And so the point that I'm mainly getting is that it takes a lot of teams and people to build software. Sometimes there's a false impression that, to build an app like Facebook, it might take maybe 20, 30 people to build it. No, it takes hundreds upon hundreds upon hundreds to build and maintain those softwares. And I did want to spend some time just talking about like what are some of the things that a coder or a developer might do. So as I mentioned earlier, one of the things that we deal with is logic. So algebra comes as an important skill to have. So in algebra, you might have like x plus 5 equals 10. Well, we can deduce that x is equal to 5 based on how algebra works. And that's a lot of times some of the logic that plays a role in coming up with what's called algorithms. Algorithms are pieces of code that have a specific function and have a series of steps that provide a certain output given a certain input. There's also things such as in software, they're called conditional statements, or a better term for that might be a decision tree. So an example might be is you're thinking about going to college, and when you go to college, there's certain things that will drive your decision, whether it be your GPA score, your SAT score, the distance from your home, the cost for the college. Those are decisions that need to be made. In software, one type of decision tree is an if-else statement. So in everyday life, we have a series of if-elses in our interactions with the world. Example can be, if I have $60 on a Amazon gift card, I can purchase my video game. But so that's if I have $60, then I can purchase the game. But then an if-else statement is taking that same if statement and extending it to provide more actions. So if I have $60, then I will purchase the game. Else, I will have to save more money. And that else statement is an indicator that if I don't have that $60, which is meaning that I don't have enough to purchase the game, then I'll do another action. And you encounter this all the time when you interact with software, and you just might not know it. Something that we have at our home is Amazon Echoes. And these are smart speakers that listen out for when myself or my wife or whoever in our home says, "Hey, Alexa." And that software on that device is listening, saying, if the customer says, "Hey, Alexa," then listen for the customer's request. And that's really what software is about, is kind of taking everyday sort of decisions and interactions and coming up with the code that is going to provide the proper output. I think that most folks might not see that in their everyday lives, but that's something that when you interact with software, there's transactions and decisions being made very rapidly on those devices. Another common sort of like coding structure or coding tool is loops. A loop is something that gets repeated over and over and over until a certain time or a certain condition is met. And we have loops in our lives all around. If you, for example, set a timer on your microwave to 2 minutes, when you hit that start button, that microwave will loop through heating your food until it goes down to 0. So it'll start with 2 minutes, then it'll go down to 1 minute and 59 seconds, and then 1 minute and 58 seconds. And that microwave is being told by the software on that microwave that deduct 1 second and update the display to reflect that 1 second, and continue to deduct that 1 second until it reaches 0. Once it reaches 0, I stop heating my food, or the microwave stops heating the food. And that's what a loop is. It's continually performing the same action over and over until a certain condition is met. And these are sort of like the tools in the tool belt that are available for a developer to use in order to come up with software. I can maybe share my screen a little bit. Let me see if I have that option. So can I hear from someone if they're able to see my screen?
Yeah, we can see it.
Okay, great. All right, so let me see if I can zoom in a little bit. Awesome. So I just got a new computer. As I mentioned, I just started a new job this week, so I'm still setting up my computer. I wish I could zoom in a little bit better. But one common thing in programming is when you're learning like a new language, we tend to refer to working in that new programming language. In this case, this is the Java programming language, as your first program that you write in a new language is called a Hello World program. And basically, it's just to get you familiar with what's called the syntax. And the syntax is just the set of keywords in writing style in which you write your program in. So in this program, it is basically saying system out dot print. This LN stands for line, and it just says hello world. And all this program is going to do is print out hello world. And it's a very simple and straightforward program. This overall tool that I'm using here, that I'm showing in this window, is it's called the IDE, or it's a integrated development environment is what IDE stands for. So it allows a coder to test their program as they're writing it. There's something called debugging a program, and a IDE allows a programmer to debug the program. And then I mentioned earlier the if-else statement, or in this case, a if statement. So in this example, I have declared a variable. So declaring a variable is basically assigning a value to a store. So assigning a value to X. So I'm assigning the value of 18 to the variable X. And then in the next line, I'm assigning the variable 20. I'm assigning 20 to the variable Y. And then in the following line, I am doing what I referred to earlier as a condition. In this condition, if X is greater than Y, system.out.print line, X is greater than Y. In this case, because 18 is not greater than Y, this statement will not get printed. And this is sort of how a program would evaluate this statement. If I were to change this number to, let's say, like 25, then if this program was executed, then it would print out this line. So that's sort of an example of what a coded a coded conditional statement would look like. I'm gonna stop sharing my screen. Okay. So I think that's a good summary of what I do day to day. I didn't know if anyone had any questions.
Yeah, let's, thank you, Justin. Let's
Sure.
move into the question answer portion. So we only have about 5 minutes for this before I let you guys fill out your rapid feedback forms. So if any students in your classrooms have a question, you can do this one of two ways. You can send us a chat, let us know what school you are, and you can type your question and we'll read it. Or if the student would like to ask the speaker the question, you can unmute your, send us a chat and let us know. And then I'll call on your school to unmute your camera and you can ask the speaker directly. All right. While students are thinking about questions that they might have, and if they want to type them and send them in or ask them, Justin, would you just share what did you study at college, and
Sure.
maybe where did you study for students who might be interested?
Sure. So my degree was in computer information systems. I studied at a university in Virginia named Hampton University. And then I went on to get my master's degree in information systems at a university in Philadelphia called Drexel University. And for my role, I would say that there is opportunities for students to go in and get degrees such as computer science, as well as math degrees, and join the software industry. But there's other options as well for folks that are not going straight to college. There's coding boot camps and other opportunities in which people can learn to code.
All right, it looks like we have a question from a student of how long have you been there for? I think they mean in your current position.
Sure. So I mentioned earlier, I was at my prior employer, Comcast, for over 9 years. But then just recently, I actually decided that I wanted to try a different environment and get out of my comfort zone. And I just joined a new employer on Monday called Dell. I'm sure you're familiar with like Dell Computer and so on. I started there on Monday, but prior to that, my last job was for over 9 years.
Cool. Congratulations on the new job.
Thank you.
All right, so we have another question. What's your favorite part of your job? And this is also from.
Sure. I actually like solving problems. So with the job, there's always going to be things that that will require like troubleshooting to figure out how to solve that problem. And sometimes that can be discouraging, but I found that one technique that has helped me with problem solving is the technique of deduction. So deduction is sort of like you have this big problem, but then what you want to do is try to shrink it so that you can focus in on the real thing. So you sort of figure out, oh man, all these things are not acting right. All right, let me take one of these and look at that specific one to see if I can figure out what's causing this thing not to run correctly. And by deducing it until you kind of have just a small problem that you're looking at, it helps you to solve that problem very quickly.
Wonderful, thank you. This is the last question that we'll have time for before we let you go. How long does it take to design a program?
So that's a great question, and it varies. So with different programs, it might take maybe a week to come up with what's called a proof of concept. But for larger programs that require a lot of testing and a lot of thought, it can take years. It can take maybe up to a full year or two to complete a workable prototype of that software. But what's good with software is that you can continue to iterate on it to make it better. Just like on your cell phone or your smartphone, you'll get updates to your apps. And what that is that software is never really complete. It's always a work in progress. So you always have opportunities to upgrade it, to add new features or make it better.